Hello, this is question 15 on your June 2018 AS paper from Edexcel, and it's an integration question. So we have a sketch here of a curve C, which has this equation, a line L, and they say the point P for 6 lies on C. So this point here, P, is for 6. The line L is normal, so perpendicular to the curve at P. So this is normal. The region R, shown shaded in figure 4, is bounded by the line L, the curve C, and the line X equal to. So we have this area here, and this is X equal to, this is the curve, and this is the line. And we have to find the area, or we have to show that it's 46. Our area, if you see, is like a bounded or limited by a bit of the curve and then the line. So one thing that we could do to make things easier is to split this into areas. Yeah, that way this one would be just limited by the curve and this one will be limited by the line, and then we can add them. So we can do this. To find this one, I just have to integrate the curve between 2 and this point. This point, or this value of x, is 4. So I just have to integrate between 2 and 4 my curve. And that's what I'm going to do first. So A1, I'm going to integrate between 2 and 4 my equation. And I'm going to write this in the numerator to make things easier to integrate. So 32x to the power of minus 2 plus 3x minus 8 dx. So I integrate that, and I have 32x to the power of 1 more, which will be minus 1, and divided by minus 1, I'm going to put the minus at the front, plus 3x squared divided by the new exponent, so divided by 2, minus 8x. And I'm going to substitute all by 4, and then all by 2, and subtract. And all this is 10, yeah? So we have a very, very nice value, 10. So that means that this area here is 10. And now we need to find this area, but this area is just a triangle. We know this side. This side is the y of P, which is 6. So we need to find only this side. This line is normal to this curve. We know the point. If we find the gradient, we will have the line. And if we have the line, we will find this point. And that's what we are going to do, yeah? So to find the normal line to a curve, we are going to find the gradient of the tangent, which is given by the derivative, and then the reverse and negative to find the gradient of the normal, yeah? So let me do it step by step. So the gradient of the tangent is going to be given by the derivative. So I'm going to differentiate this expression here. I'm going to use this way of writing it. It's just easier. So I have, when I derivate, I have minus 2 times 32 is minus 64. X to the power of 1 less is minus 3, and then plus 3. So this is giving me the gradient at any point, but I want the gradient when when x is 4. I want the gradient at P. So the gradient at P, if I substitute x by 4, I have, this is minus 1 plus 3, 2. So the gradient of the tangent, I'm going to write it to say that is the tangent, is 2, which means the gradient of the normal is going to be minus 1/2. So the normal line is going to be y minus the y of the point. So normal line, I know the gradient and I know 1 point. So y minus the y of the point, y minus 6, is going to be the gradient, x minus the x of the point, and the x of the point is 4. So this is equation of L. This equation of this line, right? The point where that intercepts the x-axis is when y is 0. So the only thing I have to do is to make this y 0. When I make y 0, I have x is 16. Yeah, so this point here is 16. And now I know my triangle, because my triangle is going to be 16 minus 4 is 12. So the base is 12 and the height is 6. So the area of the triangle, my A2, is going to be base times height divided by 2, and this is 36. So A1 is 10, A2 is 36, which means that R is going to be A1 plus A2 is going to be 10 plus 36 is 46. That's exactly what I have to prove. Yeah, and that's all with this question. I just would recommend you to, when you have to find areas, integrating, just see how can you split your shape in case it's not just one curve and you have something else, in shapes that you can find the area independently. Yeah, but that's all.